Hello and welcome to this question where we're going to look at a mechanics question. So two small balls P and Q have masses 2m km where k is less than 2. Balls attached to the ends of a string that passes over a fixed pulley. Systems held at rest with a string taut and the hanging part of the string vertical shown in figure 1. So that's a standard setup, and the only useful information here were the masses. The system is released from rest, and in the subsequent motion, P moves downwards with an acceleration of 5g7. So from here, that is useful for us to know because we know then that this is accelerating downwards, so 5g/7. And then these go through moving freely, modelled as light and extensible, modelled as small and smooth. And using the model, find in terms of m and g the tension of the string. Okay, so for the first thing that we've got then is we want to have a look at the different ones. So the formula we're going to use here is F equals ma. Going downwards, the forces going downwards is the weight, and going upwards is the tension. So the tension goes up here, the weight goes downwards. We are moving downwards because it tells us that we're moving downwards with magnitude, so we're going to take downwards as positive. So therefore weight is equal to mg, and therefore we're going to have 2mg, because the mass is 2m, minus t is equal to ma. So that's going to be 2m times 5g/7. And then we can then simplify that a little bit more because we can just say that this is equal to 10 mg/7. And then the next part that we have, okay, so explain in terms of m and g the tension in the string. So here we just want it in terms of m and g, and we want to find tension. So my first one was to actually look at Q, but Q, we don't need it, I think, because here we've got all the components. So we're just going to rearrange. We're going to move tension to the left-hand side and 10 mg/7 to the T to the right-hand side, 10 mg/7 to the left-hand side. So we have 10 mg minus 10 mg, 2 mg minus 10 mg/7 is equal to T. And therefore we can simplify this down because that's going to be 2 minus 10/7, which is just 4/7. So it's 4/7 mg is equal to T. And that gives you your first part of the question. The next part of the question, explain why the acceleration of Q also has a magnitude of 5g/7. This is because the string is inextensible. So if the string is inextensible, it means that both particles will experience the same acceleration. The string doesn't stretch, the string doesn't change. So throughout the whole string, it will have the same acceleration. Well, in this case, the acceleration is going upwards, not downwards, because it's pulling this upwards. But essentially, it will be accelerating with the same magnitude. Either on this side, it's going to be accelerating upwards. On this side, it's accelerating downwards. And that makes sense if you think about it in real life, in terms of this side accelerates upwards and then the other side accelerates downwards. So that is the reason here. So just to explain, you could just simply say that the string is modelled as being inextensible, and that will be enough. Part C, find the value of K. So here we're going to go and look at our Q value and what's happening at Q. So at Q we're going up tension and we're going down an mg. We know that the acceleration here is going upwards at 5g/7. So from here we're going to do tension minus mg is equal to, and here we need to be careful because it's kmg, and it's going to equal km times 5g/7. And then from here we can rearrange because we know what the tension is. So we found the tension in part A. So if we have a look at the tension here, it's 4/7 mg. So 4/7 mg, and therefore we have 4/7 mg minus kmg is equal to kmg times 5/7. It's a very odd way of writing it. Okay, and then the next step then is we can get rid of all the mg's because it's the common It's a common factor, so we end up with 4 over 7 minus k is equal to k 5 over 7. Move k over to the other side, we end up with 4 over 7 equals 5 over 7k plus k. And then here we can simplify this, so we do 5 divided by 7 plus 1 is 12 over 7. So 4 over 7 is equal to 12 over 7k. And if we rearrange this, this ends up as 4 over 12 is equal to k. So k is equal to a third. And that's your final answer. And then the final part, identify one limitation of the model that will affect the accuracy of your answer. You could say, well, you could say anything really. There's lots of limitations. The first of all, you've got the pulley. So the pulley is small, so it might have a mass. So currently you're saying that the pulley doesn't have a mass. You could say, well, actually no, really about the pulley. You could say the pulley is large. You could say the pulley is not smooth. Sorry, that's probably a better one. So the pulley is not smooth. You could say the string might have a mass. You can also say that I think that would be enough. I think those are the two main ones that they want you to have. So pulley is not smooth, or the string has a mass. They're the two common ones that I would focus on. There are other ones, but to be honest with you, those two main ones. I would avoid in this question using air resistance, because the bigger reason is because of either the friction due to the pulley or the fact that the string has a mass. Anyway, that is the end of this question.